Hi, I'm Rex Black, President of RBCS. Welcome to the RBCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows.
On behalf of RBCS, welcome today to this webinar on enterprise challenges of test data. Thought I'd try something a little bit new for just a few minutes, so I am going to turn on my webcam. Those of you who've never seen me on these things, now you know you got a face to put to the voice temporarily. I'm going to turn the webcam off here shortly once we get fully underway, because I don't want to devour a whole bunch of bandwidth. But I did want to say good morning or good afternoon or whatever time it is wherever you are. Thanks for coming, and look forward to having you in today's webinar. I am Rex Black. I'm president of RBCS. We are a global QA and testing firm serving clients ranging from small startups to Fortune 20 global enterprises. I've been around since 1994. In addition to running RBCS, I am also the past president of the ISTQB and the ASTQB, and currently still a director in those organizations. And I'm the author of 13, coming up on 14 books on software testing. So welcome to today's webinar. I'm going to turn off the webcam here. Purposes of saving bandwidth and avoiding slow response time on the slides. I want to mention that today's webinar does earn PMI PDUs, so thank you to Morale Gathula for reviewing the materials for PDU status and for making valuable suggestions. You will receive an email which will tell you how to claim the PDUs, including the PDU code. Due to rules made by PMI, PDUs are available for live webinar attendance only. If you have any questions during the course of the webinar, submit them at any time via your webinar interface. I will be answering them at the end of the presentation. Hope you enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community, because at RBCS we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com or via our website. All right, so today I am talking about the enterprise challenges of test data, which, for those of you who are working in an enterprise such as a bank or insurance company or a similar large organization, or for those of you who make software that's used by enterprises, these are all challenges that will be relevant and important for you to be able to address. So what are some of those challenges? Now, if you are working with simple applications like mobile apps, a lot of this discussion that I'm going to have today, the information I'm going to present, may seem, I wouldn't say irrelevant, but not necessarily immediately applicable to your situation. Because representative test data is not all that hard to come about or come across, create. But if you're testing enterprise scale applications, it's a different story. Typical enterprise data centers, you've got dozens or hundreds of applications that are out there in the data center. They are running on various physical and or virtual servers. Applications can be small, 1 week coding kind of things. Some of my clients have, all the way up to enormous applications that are produced by hundreds of developers. and testers, and may be customized for use by this particular organization in their particular enterprise data center. The repositories are often large and disparate in some cases, or maybe a mix of large and small, and in some cases they are shared. So data that's used by or created by one application might be used by 2 or 3 others, and sometimes data can be created and updated by multiple applications, which creates some additional interesting factors. So what we're going to do is look at different options associated with test data and the challenges that are associated with them, so that you have a better understanding of what you're up against and an ability to deal with it more effectively. Now, first off, let's just look at options for sources of test data. The simplest is to generate the data by hand. By hand here, I'm really referring to using some simple thing like Excel or Access as a way of kludging up the data, or getting a tool, open source or commercial tool, to do test data generation. This is another option. Now, that's sort of on the simpler end of the scale. The other end of the scale is to use production data, either all of it or some significant subset of it. This data may be used directly in its raw form, as it were, straight from production. Though that can create some problems, so that it's often necessary to anonymize or pseudo-anonymize, also called obfuscating or scrubbing or masking, the production data. We'll talk more about that later, because that's a major issue. Now, it's not like hand or tool or production, really, but it's like some amount of hand-generated data, some amount of tool-generated data, mixed with some amount of production data is often the best idea. Usually some amount of tool support is going to be needed if you are doing this at an enterprise scale. It's pretty unusual that you would be able to do this without any sort of tool support at an enterprise scale. Smaller apps, maybe so. Larger ones, no. Especially not hundreds of apps. Now, a couple caveats before we jump into the different challenges. You want to be very careful about any use of production data in the production environment for testing. Now, I understand that this, testing in production and A/B testing are all kind of the rage now. I don't know that there's been enough attention paid to the amount of care that needs to be put into doing that in a way that doesn't potentially result in damage to the production data. And depending on how valuable your production data is, that could be a pretty big deal. There was an infamous scenario a few years ago where people were being encouraged on this particular T-Mobile mobile phone account to use their cloud-based photo saving and sharing service for their mobile phones. And this may or may not have happened as a result of a test. I don't remember exactly what the cause was, but a bunch of the photos got deleted, and it turned out that the backups didn't work. And people were, not happy. Now, of course, the agreement was written in such a way that they couldn't get sued, but you can bet that some of those people who lost some pretty valuable photographs, at least in their opinion, are ex-T-Mobile customers for the rest of their life. You also want to be careful about any sort of leakage of test data into a production environment. My favorite example of this was a UK-based utility company that was doing a test of a mail merge letter that was going to get sent out to all their customers. This mail merge letter somehow got into a production environment and got sent out to all their customers. And the letter opened with the salutation, "Dear Idiot," and then kind of went on from there in a similar vein. you can imagine that there was a fair amount of back rowing and backpedaling that had to happen after all of their subscribers got a letter that started with "Dear Idiot." So there's a couple lessons there. One is, be careful about leakage of test data into a production environment, and don't put anything into your test data that you wouldn't be happy to show to a customer or end user, or your mother for that matter. Now, test data is not always complicated. And again, some of you who are working in simple settings might look at this, the rest of this discussion and say, I really don't understand a lot of that stuff. Why is it so complicated? Because, if you think about a simple mobile app, your situation might look a lot like the graph that's shown at the bottom of this screen. Let me get my spotlight up here. So I got a mobile app running over here on a mobile handset, and then it's like going into the cloud and out into a web server, and then through from firewall, and maybe there's some app servers and other stuff over here. But eventually there's a database, and there's a single database, and it's not nothing terribly complicated. The data is going back and forth. All right, that's fine. If your production data is not very large, you might be able to just use that to populate your test database. Or you might even just generate the data, using a tool. It might be easy enough to generate enough data that it looks a lot like the production data. But, you might say, well, there's no personal identifying information in the production data, so I'm just going to use that because there's no risk associated with using that data. So this could be pretty simple, and maybe this is where you're at. Don't count on being at this place forever, though, because these things change, and you might, in jobs change, you might find yourself in a situation that looks a lot more like this. So let's take a little trip around the world in this sort of mock-up of the enterprise scenario. So here we have the enterprise data center, and we've got a whole bunch of stuff. We got a firewall. Firewall here. We got the network, security appliance acting on the data, web servers, app servers, mainframes, databases of servers of various kinds, and then all sorts of different databases. And we've got who knows how many. I'm showing 1, 2, all the way up to N. Some of these might be relational databases. Some of them might be the Hadoop, NoSQL kind of stuff. Some mix of those could be happening. You could even, you got a mainframe in here, you could have some ISAMs. Those of you who remember what an ISAM is. I could have that. I could have some tree structures, C tree, B tree type of structure databases in there. That could be going on. And then I've got the back office. The folks in the office that are working and accessing the data center might or might not be physically in the same place. And there's Wi-Fi. I've got people working from home, and I've got retail locations potentially, and I've got satellite offices that might have replicated databases and maybe some local databases. And this is, as complicated as this might look, actually way simpler than the reality, because generally there's a whole lot more applications and a lot more databases, and just a lot more stuff, a lot more offices. So this is where things get fun and interesting. So you might say, well, we got all these databases. Is it possible to generate the data by hand? No, no way. I mean, you got large-scale systems, and they've got gigabytes of data potentially that's been accumulated over decades. In some cases, you're not going to be able to create enough data. And even if you could get a data generation tool and create a large volume of data, your problem will still be with the sufficiency of diversity and the differences in value distributions and other attributes. In other words, it just won't look like production data. there are so many nuances to the production data, and replicating them by hand is super complicated. Even doing it with a tool, you have to express the complexities of the data in the tool in order for the tool to generate those complexities, which means that you actually have to be aware of those complexities, which maybe you are, maybe you're not. The odds are pretty good that you're not unless you have done a really, really detailed study of your data. Because as I said, this data could be accumulated over the last couple decades, so it could have all sorts of issues associated with it, vagaries of one kind or another. So the gold standard for testing is just to say, hey, let's just go get the production data and we'll use that, because that's great, because that looks exactly like what the application is going to be dealing with when it gets put into production. Now, of course, one of the problems with production data is it's all entirely retrospective. In other words, it only includes the data that's been created so far, obviously enough. The new application or new features for your application and so forth that are being released, which is why you're testing, may very well have some implications from a data point of view that would have to be generated and added into the test data. But, you know, having done that, you now have this data that looks like what your app is going to be dealing with, at least to the extent that you can think of it. So that sounds great, except stuff. Lots of stuff. Privacy stuff. So the thing is that in a lot of applications in the enterprise, the production data contains personal identifying information. And, you know, at the very least, you should be nice to your customers and not let that stuff out there. Now, you know, as I said in a LinkedIn post not too long ago, you know, corporate values are what the company does when they think social media isn't looking. So it's sometimes not always clear as to how much self-initiative is going to be taken with respect to protecting people's personal identifying information. But, you know, at some point, laws kick in a lot of cases. There's a new law coming out in the UK and in Europe shortly that's going to have to do with general data protection rules. And generally, the European laws are a lot stricter on this than they are in the US. But the thing is that if you operate multinationally and you're operating in Europe, you're going to end up being kind of drawn into that. Now, some companies try to dance around this by saying, well, what we're going to do is we're going to use production data for testing, but we're only going to allow people who are employees and already cleared to see that data to see the data. Now, I mean, this is, of course, a violation of a basic principle of security called least privilege, which is that you don't show people information about other people that they don't need to have. There's a need to know principle there, or more broadly called the principle of least privilege, which means that basically people are only allowed to do the things they actually need to be able to do their job. And seeing someone's social security information or social security number or credit card number or something like that is typically not in the tester's job spec. So trying to dance around this by using employment as a, well, they're employees, so we trust them, is really just, you know, a sham. And plus, the organizations that I've seen try to do that, it is so inefficient and so constrained and put so many burdens on attempts to do distributed or outsourced testing that eventually they give up. So what you want to do to deal with this when you have personal identifying information, which a lot of times you will, is use some sort of anonymization tool. And they will help, but the thing is that it's not, they're not magic wands. It's not like you just go out and get a data anonymization tool and go Shazam on a data set and then all the problems are solved. It's actually, you have to understand and then explain to the tool effectively how to anonymize the data to obfuscate, mask, or anonymize personal identifying information. And if you don't do that right, if you do a sloppy job of it, then you will get situations where the reversal of the anonymization is trivially easy. Any moron could do it. Even if you do a reasonably good job of it, but you screw something up, you could easily have a situation where personal identifying information is leaking out. And part of the proof that organizations do such a lousy job of protecting people's private and personal identifying information is all of the hacking that goes on. I mean, they're after people's information, right? And if organizations were actually doing a competent job of managing personal identifying information, that a lot of the incentive to hack into companies would disappear for a lot of these criminal hackers. So, just try to do a good job here. Don't be part of the problem. At least, try to be part of the solution. Now, you have to be careful when you do this because you want to make sure that you anonymize in a way that completely protects people's privacy and their personal identifying information, but at the same time preserves meaning and meaningfulness of the data from a testing point of view. So you might be thinking, what is he talking about, meaning and meaningfulness? Well, let's look at an example. So to anonymize data, you often have to change somebody's name from their real name to some name that looks realistic but is not actually their real name. So we could, for example, change John Brown into Lester Camden. That's a good substitution. Those are both male names. They are both generally sort of Western European surnames and typical first names for people of Western European heritage. So we haven't done something weird ethnically or gender-wise to John. Now, in the second example, though, we have done a gender reassignment on John by changing him into Charlotte, which my daughter's name is Charlotte, so I'm assuming most Charlottes are daughters rather than sons. And we've also transposed his heritage from one end of the European continent to the other, which, Dostoevsky is a fine name, but it is not a Western European name. It is an Eastern European name. So now, that's going to create some problems. Maybe, John Brown is a member of the Sons of Scotland interest group or something like that. Well, Charlotte Dostoevsky is an odd person to be a member of the Sons of Scotland interest group. So if that's part of the data that you're keeping about this John Brown, as soon as the John Brown becomes Charlotte Dostoevsky, that doesn't make a whole lot of sense. And so the meaning and meaningfulness of the data has been compromised. Now, this gets even more fun when you start thinking about queries and views and joins across multiple tables. You need to get the same results. So if, for example, customer John Brown has 50 entries in the transactions table, then Lester Camden better have 50 entries in the transaction table as well. So in other words, when we do a query that joins the customer table with the purchases or transactions table, we should see that there were 50 purchases. If that changes in some way, there's more or less, then that has implications from a functional testing point of view as well as a performance, reliability, and load testing point of view. This can also have localization implications as well if it's not done right, both functional operational localization issues as well as the user interface character localization issues. When you're changing somebody who's got a name that's in, say, Chinese characters or Japanese characters or Cyrillic or what have you, that needs to work as well, and it also, again, needs to follow these same rules. Now, you might say, okay, well, we're doing this anonymization in a relational database, so shouldn't that issue that I was talking about with the queries, views, and joins be handled by the relational integrity? Well, it might or might not. And when you get into situations where you have data and relationships between data that span multiple databases, then this gets really easy to break. So if you look at the example on the slide here, let's say we've got 2 decades of data that describe roughly the same population, such as a company, a bank that buys another bank, and then it goes and buys an insurance company. And so some of the people who were customers at one of those companies were also customers at other of those companies and have accounts or policies in those other companies. And so now we've got, John Brown is not just in one database. John Brown is in all 3 databases because he has a policy from the insurance company and a CD from one of the acquired bank, as well as being a checking account customer of the first bank that did the acquiring. And so now people start to create these applications in the data center so that they're interoperating and sharing data, because after all, that does make sense. You want to be able to do those kinds of queries across shared data repositories. And even if you don't have the applications interoperating, there's business intelligence, data warehousing, data analytics kind of stuff that's going to want to be able to explore across the different databases. So effectively, when you do that, you are creating logical records the same kind of way you do with the select statement in SQL that works across a join, except that in this case, these are de facto joins across de facto foreign keys. And if you're like going, I have no idea what he's talking about, you definitely, one of the things you'll need to do when you're thinking about test data here is do some reading and some studying on relational databases, because this stuff does really matter in terms of how you manage the test data. So if you don't have the integrity constraints, relational integrity constraints that would exist within a single database, which you will not here with disparate databases, it's really easy for the anonymization process to break the integrity constraints. So when those integrity constraints get broken, while I can do testing of an individual application, then any sort of end-to-end test that spans multiple applications, in other words, system integration testing, or sometimes called string testing, is not going to work the same way as it will in production. So that's got functional implications, it's got performance throughput implications, it's got reliability implications, localization implications, security implications. So I can test those things, but the odds are that since I'm dealing with a data set that's much smaller than what's going to happen actually in production, that my results are not really meaningful, that I'm going to get a lot of what are called false negatives. In other words, tests that pass that actually should fail if I were testing them against proper data. So this is not just an anonymization issue. I'm sort of kicking the anonymization tools right now for not being able to handle this effectively. But the thing is that it's not just a matter of the anonymization is not doesn't handle it effectively. It's if you hand generated this data or generated it with a tool, you'd have real challenges in getting this right as well. So that's one of the things to look at is make sure that when you're doing the anonymization, you're not going to break that data from a interoperability testing perspective. Now let's pop up to a sort of a different level and kind of look around at what we want to say about test data requirements in general. One of the things is that we want the data quality level to be about the same in our test data as it is in our production data. Now you might say, data quality level, what are you talking about? Well, the studies that I have looked at over the years have pretty consistently shown that about 25% of records in databases, including safety critical databases like hospitals, will contain errors in them. Those errors may be something as simple as somebody's eye color is coded wrong in the DMV database, which is probably not a huge issue unless somebody ends up improperly on the most wanted list. But it could be something more significant like blood type. So if you test with data that is pristine and without error, then there are things that are going to happen in production that are associated with the errors in the data that you're not going to see in testing. So here we are, false negatives again. So you need to figure out, do some study of your data and look at what the error rates are and see how to replicate that in your test data. But you have to be careful that you don't want to in any way enable reverse engineering of the anonymization if this is if this data, these errors in the data are something that are going to give hints as to who's who. Because keep in mind that it's possible to using data analytics and business intelligence tools now to do tremendous amounts of analysis on data. So a hacker gets a hold of all of the data, and they can look at ways to reverse engineer it. Now, another thing to keep in mind is it's not just about generating the data. Test data management needs to take into account the ongoing management of the data. So you want to make sure that you're doing this in a way that is maintainable, that it'll be possible to edit data, to add data, to update data, to delete data. And I'm talking down at the individual field level all the way up to logical records that span multiple databases. And you want to make this something that can be done in a realistic amount of time. I've had clients tell me that they only refresh their test data from their production data every 2 years because the process of doing the test data refresh from production can take 2 or 3 months. And the reason for that is that they did not include any sort of incremental or differential kind of update capabilities, and so they have to do it every time from scratch. So that really sucks. That is tremendously inefficient, and you don't want to do that. You also have to be careful that when you are copying production data, if that's what you're going to do, or anonymizing directly from it, that the data is what's called quiescent, meaning that you're not having changes in tables that are creating referential integrity problems with data that's already been copied or anonymized. A simple example of this is basically selling the same seat in a concert hall twice because you have 2 different copies of the data that both show that seat available. Okay, now that's not a perfect example here, but it's one that I think is pretty easy for people to relate to. Now, another important challenge of enterprise test data is just the cost of the database server. If you're going to try to deal with production scale test data, it needs to have a home, and there might be some licensing costs associated with that database management system. There's the server, there's the disk. And you can say, well, servers are relatively cheap now, and disks are relatively cheap. Disk space is relatively cheap. Well, that's true, but there's cheap and free are 2 different words. And there's hardware and software maintenance, and there's backup, and all of those things. Not only are there like costs, associated with the physical stuff, there's costs associated with people's time. And if you say, well, we're an open source shop, we only use open source, so we're going to have an open source database management system. Okay, goody for you. That deals with the database management system licensing costs, but the total cost of ownership of open source software is not 0. So something to consider. Now, one of the things that's definitely underutilized and can help you here potentially is storage virtualization. I was at a conference a couple weeks ago, and there was a vendor there. I think it was a company called Delphix. It just happened that right after I gave a presentation, this presentation, in fact, at that conference, they got up and said, "Oh yeah, well we do this." Now I'm not endorsing them. I don't really know these guys from Adam, but I mean this is an example of this kind of tool. So if you're wondering, you can go take a look at it. See, when people hear virtualization, they just think, oh, cloud, virtual servers. Well, yeah, server virtualization is one thing, but storage virtualization is a different kind of thing that you need to do some study of this if you want to get your head around what it is. But go take a look at some web resources on it and read up on it, because this can help with not just the data storage, but also the whole cost of allocating and deallocating the data. It can help with that, though there's still the issue of anonymization, but done properly, only the stuff that is actually being anonymized or scrambled will be a second copy. So this allows you to significantly reduce the amount of additional data required to have a copy of the production data appropriately anonymized. Because you'd think that, okay, if I have an anonymized copy of the production-based data, basically I got to take however many terabytes I've got in my production data and double it. But these kind of storage virtualization tools can take a significant bite out of that. I forget what their figure was, but it was somewhere in the 25% range rather than 100% range. Of course, that depends on how much data you're dealing with and how much data you have to anonymize. Now, this is not just an issue of cost of the storage, but it's an issue of the time associated with dealing with it, dealing with the data and moving it around. What we have in the computer business, of course, is Moore's Law, and Moore's Law has been our friend. And of course, Moore's Law is basically an extrapolation. I mean, the original Moore's Law applied to the transistor density of CPUs, but it turned out that Moore's Law applied to a whole lot more than that. It's applying to technological change in general. Excuse me, but the problem is that Moore's Law has not been the same kind of friend across technology of all different kinds. It's been a friend, but in a different way. So if you look at this graph here, which is conveniently provided by Tyler Muth blog posts here, you see from 1979 to 2011 changes in two things: capacity, which is the blue line, versus throughput. Now, I will point out this is a logarithmic scale. Okay, so notice that when you have straight-ish looking upward pointing lines in a logarithmic scale, what you're looking at is an exponential type of growth, right? So what we have here is that nice exponential growth of capacity and a nice exponential growth of throughput too, except the problem is that the throughput growth is way, way, way less. So basically what we have is that you can move a terabyte of data 72 times faster now or in 2011 than you could in 1979, but you could store 82,000 times more data in the same amount of space. So instead of once we would be moving a gigabyte, and now we're moving 82 terabytes. But the fact is that it's only going to be about 100 times faster on a byte per byte basis. So ouch, that's a problem, right? That's a huge problem. And this means that moving data around is a painful process. So this is again why issues like storage virtualization might be valuable, because as you get up to production size, you are talking about terabytes and above. Now, another wrinkle from a test data support, test data management angle, which you need to have as part of your requirements when you're thinking about how to come up with a test data management solution, is issues associated with specialized application support. So, you could have something like SAP, or in some cases you could have tools that are a whole lot older than that. I've had some clients mention to me tools that are like decades old that nobody supports anymore. So this can be kind of a problem, because the bigger, more popular tools, you may be able to find data anonymization or data anonymization tools for those enterprise management applications. But if it's something that's old, it's been pretty much withdrawn from support, maybe you can't find a tool. If there's some sort of weird data format, there might not be an easy way of anonymizing that or managing that data. Even if the application vendor is still around, they may say, well, you know what, our contract says that we don't have to share metadata with you, and so we're not going to tell you what the data structures look like. And oh, by the way, your contract precludes you from reverse engineering our code, and that also includes the data structures and the metadata, so you're not allowed to do that. Oh, you want help with anonymizing your data for testing purposes? That's fine. At our usual and customary consulting rates, we will be happy to come in and do that for you. Our usual and customary consulting rates start at $500 an hour. That may be a little bit more than they would end up charging, but maybe not. It probably depends on how fully they feel they have you over the barrel. Now, it would be nice if this were all taken into account during enterprise application selection, but testers generally don't get included in those discussions. So this can be a real problem that you discover that, okay, guess what? There's this huge repository that's central to the way we do business, and we can't anonymize it because we can't get at the data, or we're not allowed to get at the data in a way that wouldn't violate our contract. Now, some organizations will just look at that and go, hey, sue us. We're going to reverse engineer the structure, and we're going to do what we need to do because we're caught between an obsolete contract clause and lack of support on the vendor on the one hand, and the obligation to protect the privacy of our customers and clients on the other hand. We claim sort of force majeure, but you don't want to just do that yourself, because you don't want to be the person that made the call. That's your company's legal department needs to make the call on that. Now, this is something that I have talked about before. I'm sure there's a recorded webinar out there somewhere or another on the Digital Library or RBCS YouTube channel. If not, I'll do it soon on tool selection. Posted out there. I lose track. I've been doing these webinars for like 10 years now, so there's quite a dusty library of stuff out there that you can get at. But just to briefly discuss the tool selection process, because this is so critical, you don't want to screw this up, because if you select the wrong tool, you're going to be hobbled. So make sure that you start with a cross-functional team that represents the different stakeholder groups, and get the requirements from all the different users and all the different stakeholder groups. Don't overlook anybody. Deal with risks and constraints that are going to affect the use of the tool, and only then should you start looking at what are the possible tools. Don't anchor your thinking by looking at tools right away, because that will influence what you think you need the tool to do. You should be able to come up with 100 or so requirements, I would guess, if you're dealing with enterprise scale data. So don't shortchange that process. Go look at the tools, come up with a short list, select the tool off the short list based on your requirements, what's going to be the best fit. Don't just do it's the cheapest thing. This endless, low bidder, driving down the cost, basically chasing pennies while dollars go flying through the air stuff is really dumb. So select the tool that you need, make as few compromises as possible on that. The tool might be free, so certainly look at the open source options, but remember, free to get is not free to own, so that's something to consider. Do pilots and then gradually pilot or deploy the tool, and support the tool during the deployment process. I've seen plenty of examples where tool launches failed because the tool was selected by a selection committee and then it was just thrown out there and like, okay, here's the standard tool for doing test data management or test data anonymization or what have you, and then they let everybody figure out how to use it on their own. because that will typically not work out well. Plenty of stories of people who went through the process of getting tools, and because they took shortcuts or because they were cheapskates on this process, ended up losing a lot of money in the long run if they had a tool that they couldn't use. All right, so hopefully this has given you some idea of the different challenges that you need to deal with for test data management at the enterprise scale. Challenges associated with data, privacy, tools, size, cost, testing usefulness, etc. The objective of this presentation is to get you thinking about the challenges and understanding what you need to address, coming up with a plan. There's no such thing as an off-the-shelf plan for test data management or some kind of one-size-fits-all tool solution. Anybody who offers you that is not doing you any favors, though you may end up doing their bank account favors if you fall for it. So I hope you've got some good ideas here, something that will help you be more effective at test data management as you go forward. So this is the end of the presentation. I'm going to put the Q&A slide up, the advertisement, and before we go to the questions, a quick word about the services we offer. So as I mentioned earlier, we do have a team of international consultants that deliver customized training, consulting, and expert services to companies looking to improve their test and quality assurance practices. So if you receive valuable information from our free webinars, please help us continue to provide them by making RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help you might need, so please contact us, info@rbcs-us.com. Okay, so let's see, what do we got in the way of questions here? Ian had mentioned this thing of local data protection laws earlier in the presentation, and then said, oh yeah, slide 4 answers the question, thank you. So yes, you do. You need to keep in mind local data protection laws, and if you're in a multinational firm, a firm that does business in a lot of different countries, then you could have a lot of different laws that apply to you. You think about, some of the takedowns that have occurred with Google and Microsoft over the last couple decades from European courts, which have a distinctly more individual-friendly perspective on personal identifying information. And you want to be careful about transferring over U.S.-based ideas about personal identifying information and who owns it. We have this very peculiar thing in the United States where I believe it's a Supreme Court ruling, has interpreted the First Amendment to say that gives you a right to gather data on other people, and that data belongs to you, and that's free speech, which is perplexing to me, though I have to admit that I've never read the decision. But that's the root of it, is that that's seen the collection of data about other people, subject to some restrictions and regulations, is seen to be a First Amendment right. That is not in any way the case in Europe, where there is no such thing as the First Amendment. At least they don't have our Constitution, and obviously none of provisions of our Constitution apply over there. So things look differently over there. The other thing that can vary from one country to another are libel and slander laws, and so you want to don't be too U.S. centric in your thinking about this stuff. Leonie says, wouldn't the meaning of the substitution depend on the full scope of the information the system is storing? If the system doesn't care about gender, does the data substitution still have to consider that? No, it wouldn't, right? So absolutely. I mean, I gave the example of John turning into Charlotte and the sons of Scotland kind of thing. That only applies if gender is an issue and ethnic heritage is potentially an issue with respect to the data. Now, of course, the thing is that it might not be now, but it could be in the future. So it could be that somebody, some group in your company decides to introduce some new feature that actually does have something to do with gender or ethnic heritage or something, and then if you've been doing your anonymization in such a way as to ignore that, then all of a sudden you now have a problem in that your test data has been obsoleted by these changes, which is not great. See, G asks, is it common to use things like names, for example, John Brown, as a foreign key? Names are something which are likely to have duplicates, so using some kind of unique ID number is generally a better idea. Well, that's very true, but if we think back to the example that I was giving, G, what I'm talking about here is primarily dealing with referential integrity across disparate databases. So yes, within a single database, you would tend to have some sort of unique identifier that would be used as the key rather than the name itself. But the thing is that unique identifier is going to be consistently used within a single database. But as I said, if I have 3 different applications, each of which has its own database, and let's assume that they followed relational database management best practices in setting up those databases, which that could be a stretch right there, but let's assume that for the moment. So yes, John Brown is not the foreign key. John Brown has a unique identifier. Well, the problem is he has a unique identifier that's different in each of the 3 databases. And the way that the data analytics tools are probably going to be joining across those databases is based on things like name. And so if I change the person's name in a different way across the different databases, then bang, I've just now broken that referential integrity. So it's not an unsolvable problem, but it is a problem that's not going to solve itself. It's something that you have to think of as part of this process of test data management. All right. A few interesting questions there. Seem to have gotten to the bottom of the question list. So I guess this was either so completely enlightening to all of you that you have no questions, or you're sitting there in stunned silence trying to formulate a question. But either way, the questions are done. So thank you for the questions. To close this session, please remember that we run these free webinar sessions once a month. Go to rbcs-us.com to sign up. While you're there, please sign up for our free regular newsletter to get valuable discounts on consulting and training services, and the regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can follow me on Twitter and Facebook and LinkedIn and YouTube. As you can see here, the stuff that comes out once a week, or in the case of LinkedIn and YouTube, it's about once a week, or maybe 3 or 4 times a week. And in the case of Twitter and Facebook, it's a couple times a day. This recorded webinar will be posted shortly. So if there's anybody that you think could have benefited from hearing this, it will be posted here in the next 48 hours or so. The blog is back, so rbcs-us.com/blog. There's new stuff out there about every other day. We offer these free resources as a service to the software testing community, because at RBCS we are not just for-profit company, but don't forget, we need to keep the lights on. So please make RBCS your preferred software testing vendor for any and all expert services, consulting, and training. Concludes the webinar. Thanks to everyone for joining us, and I'll see you next time.